Watch this stream of raw numbers organize into a structured grid and then build into a clear bar chart. That sequence is the entire Python data analysis pipeline in 3 steps: crunching the raw numbers with NumPy, organizing them with Pandas, and painting the final picture with Matplotlib. This is a linear sequence of numbers from 1 to 20. NumPy acts as the engine for operating on this raw data. By passing this array through np.mean and np.median, we locate the mathematical center, exactly where the dividing line sits between 10 and 11. But real-world data rarely exists in a flat line. To handle multiple dimensions, we can take a 16-element array and apply the .reshape 4x4 function. This instantly forces the data into a 2-dimensional matrix. Once the data is in a matrix, we can manipulate its structure. By calling .t, we transpose the data, swapping the rows and columns across the diagonal axis. Transforming and shaping data is the mandatory first step in any analytical workflow. Complex mathematical analysis requires a properly structured matrix before we can extract a single reliable insight. Look at this 4x4 matrix. A common friction point is axis orientation. Setting axis equals 1 forces the calculation horizontally, producing row totals. Conversely, changing to axis equals 0 calculates top to bottom, pushing sum totals to the bottom edge. With 2 3x3 grids, standard multiplication multiplies numbers in the exact same positions, but np ... changes the mechanics. NumPy multiplies a row of the first grid by the corresponding column of the second, producing a completely new matrix value. NumPy handles heavy mathematical lifting with incredible speed, yet raw arrays are completely anonymous. They lack the descriptive text and headers that human analysts need to make actual business decisions. This is where Pandas comes in. Pandas is the structural tool that assigns real-world labels to bare numbers, converting an abstract math problem into a highly organized database. We start with this basic Python dictionary containing employee names, ages, and salaries. By passing this into the pd.dataframe function, it organizes into a clean Excel-style table with explicit column headers. To isolate specific information, like salaries in the HR department, we evaluate this syntax. The inner bracket evaluates every row, creating a true or false test for the HR label. The outer brackets then apply that filter, returning only the rows that pass the test. Now that we have isolated the target data, we can aggregate it. Calling the .groupBy function on the department column allows us to attach .mean, calculating the exact average salary across every individual department in one command. Let's test this logic. Pause the video and write the exact Pandas syntax to filter this data frame for employees who are 25 years or older. To apply the true or false test, you write df, open bracket, df bracket age greater than or equal to 25, and close the bracket. Querying and organizing tables with Pandas allows us to extract highly specific, actionable answers from what would otherwise be a chaotic set of records. The final stage of the analysis pipeline is translating our structured answers into human-readable graphics. We do this using Matplotlib. This pie chart displays revenue distribution across 4 global regions. To emphasize the North American slice, we use the explode argument. By passing an array with a 0.1 in the first position, we physically separate that specific data point from the main circle. Getting the exact percentages to display requires a specific formatting string. Looking closely at AutoPCT equals 1.1f%, the first section tells Python to calculate the number to exactly 1 decimal place, while the second section instructs it to print the literal percent sign right on the chart. While pie charts show proportion, what you are seeing here is a chaotic cloud of 1,000 random numbers. By calling plt.histogram, Python instantly groups them into vertical bins. This visualizes the frequency distribution of massive, continuous datasets as a clean histogram curve. This color-coded cheat sheet maps out the complete end-to-end Python pipeline. We rely on NumPy's blue functions for mathematical calculation, Pandas' green methods for structured querying, and Matplotlib's orange commands for visual storytelling. Save this framework and use it as your blueprint for your next dataset.